This diagram shows a circuit. I want you to calculate the current flowing from the source, the voltage drop across BC, the current in the 12 and 9 ohm resistor, and the power dissipated in the 12 ohm resistor. Now clearly this question is about determining current in a circuit with both series and parallel. Now to be able to determine this, the current, we need to know the total effective resistance of the circuit. So first we need to determine the effective resistance in this circuit here, as you can see. So we need to convert R1 and R2 into one effective resistance and then add it to the other resistor. This is the formula, so all you do is, this is the formula here, you put the numbers in, 1 divided by R equals 1 divided by 9 plus 1 divided by 12, it gives you 1 divided by R equals 0.194, it comes out at the effective resistance of R1 and R2 is actually 5.15 ohms, that's what it comes out at. Then we determine the total resistance of the circuit in series by adding them. So you've got 5.15 plus your 3, your effective resistance of the whole circuit is 8.15 ohms, as you can see there. Then we need to work out now the current. Now we know that V equals IR, you transpose that, you get I equals V divided by R. You put in your known values, it's 240 volts, we've worked out the resistance as 8.15, it gives us a current of 29.44 amps. Okay, so that's part A. Let's go for part B, which is to determine the voltage drop across BC when we know the resistance is 3 ohms. So we know it's 3 ohms, okay? Well, this is the formula, V equals IR. V equals, we know this now, 29.44, that's the current, times 3, the voltage drop there is 88.32 volts. That's the voltage drop across there, okay? Let's go for part C of the question now. It wants to determine the current in the 12 and 9 ohm resistance. Well, we know that 29.944 amps is flowing in the circuit, and this is going to be divided between the two resistors. So we know that whatever answer we get, it's got to add up to 29.44, because that's in the circuit and that's split between two of them. Well, all you do is add the resistors together, giving 21 ohms, and take away the proportion of each. You can do it like this. Therefore, 12/21 will go through for one resistor, and 9/21 will go through the other. Do you understand that? 12/21 and 9/21. Well, clearly, as the resistance to flow, the higher resistor will have the less current. So all you say is 9/21 of 29.44 is 12.62 amps. That must go through the 12 ohm resistor, and 12/21 must go through the other one, which is 16.82 amps. Do you see how you can proportion it if you know the ampage? As you can see, it adds up to give you your 29.44. So 12.62 goes through that one, and 16.82 goes through that one. Now the final part of the exercise was to determine the power dissipated in the 12 ohm resistor. And this is a formula you should be applying now. P equals I squared R. Okay, we're looking at power now. We know the current, we know the resistance. If you put in known values, we know the resistance, which is 12 ohms, and we know the current flowing through the resistor, which is 12.62 amps. If you put this in, it gives us a power of 1911 watts. That's the power in there. And that completes that exercise.